Hi guys, welcome to my channel. On today's video, we're going to be solving 5 African Mathematics Olympiad practice questions. First question for the day is, find the height of the trapezium whose area is given as 68 cm squared. Now, the first thing you need to remember is the formula for calculating the area of a trapezium. What is the formula for calculating the area of a trapezium? It is half, open bracket, A plus B, close your bracket, multiply by H. So let's write that down. Okay. So it is area is equal to half A plus B multiplied by H. Your A and your B are the two parallel sides of your trapezium. So remember that your area is 68. So all you need to do is start substituting. And you have half 6 plus 10. We don't know what the H is, and that's what we're looking for. Okay, so let's go. 68 is equal to, sort out what is inside the bracket. It gives you what? 16 H. 2 here 1, 2 here 8. So I have 68 is equal to 8H. 1 times 8 times H all over 1 is 8H. This over 8 and this over 8. So I'm looking for the H. I need to get rid of the 8 that is multiplying the H. And the only way I can do that is to divide both sides of my equation by 8. This cancels this. I have H left. I know 8 here 1, 8 here is 8 times, which is 64. Remainder 4. So I put a point here. I put my 4 in a corner and add 0 to it. Because after every decimal point, you can keep adding infinity zeros. So 8 divided by, 40 divided by 8 is 5. So H is 8.5 cm. I go to the options and I pick A. Final answer is 8.5 cm. Here we are. Second question. It says a rectangular field has a dimension of 8 meters by 3x meters. If the sides are doubled, what will be the area of the new field? The first thing I'm going to do is sketch the rectangular fields. Okay, so a rectangle, the original one is this. I'm doing a sketch, and this is 8 meters, and this is 3x meters. The question says, if I double this, if I double it, I'm going to have the first one as the length as 8 times 2, which is 16 meters. So this is going to be 16 meters. It's a sketch. It isn't drawn to scale. Then this will be 3x multiplied by 2, which is 6x meters. That's for this. And remember, area of a rectangle is given as length times breadth. Okay, so the length of the new doubled rectangular field is 16, while the breadth is 6x. Okay, so now it's time to multiply. Multiply 16 by the coefficient and you have 6 times 6 is 36. 6 times 1 is 6 plus that 3 is 9. So I have 96 meters square as the area of the new rectangle that was doubled. I go to the options and I look for 96x meters square, which is B, and I am correct. Here's our number 3, and it says a piece of rod 2 meters long is cut into 3 equal pieces. One of these pieces is then cut into 4 equal pieces. What fraction of the total length will one of the small pieces be? Again, I would like to solve this by sketching the rod and keep cutting. So let's go. I'm going to sketch the rod 2 meters long. So this is 2 meters, and 2 meters was divided into 3 equal pieces. So this is 2 meters divided by 3, 2 meters divided by 3, 2 meters divided by 3. So each piece is 2/3, 2/3. Okay, so this piece, one of it, from the question, it says one of it is then picked and divided into 4. So I'm going to pick one of it, which is 2/3, is then divided into 4. Okay, so let's divide this into 4. Into 2 first, then into 4. So I'm looking for the fraction of just one of it. So solving this will give me the fraction of one of it. So let's go. Remember division of fraction. Make this a fraction by just putting it over 1. Then you go keep the first fraction, change the division sign into multiplication, and flip the next fraction. Multiply horizontally and you have 2 times 1 is 2, 3 times 4 is 12. Break this down by dividing both the numerator and the denominator by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. The fraction of the new small piece is 1/6. So you go to the options and check which one is 1/6, and your answer is C. Final answer is C. If you're still watching till now, I want to say a big thank you to you. Don't forget to subscribe, like this video, share with anyone you think will need it, and turn on my notifications so you don't miss any math video from me. Let's keep going. Now we're on number 4. Number 4 says a teacher asked his mathematics learners the number of significant figures in 0.0080. What would be your response? So if you were asked this question, how many significant figures are in this number, what will you say? Remember, zeros that begin a number zero that begins a number are not significant. So this 0 is not a significant number. This isn't. Your significant number starts from 8. And please don't throw away the 0 after it. It is a significant number. So zeros in between, zeros after are significant numbers. But zeros that begin are not significant numbers. So for this one, there are 2 significant numbers. This is the first and this is the second. So I go to A and choose A, and I am done. Easy and fast. Here's our last question for this video. Calculate the length of a cube whose volume is 512 centimeter cube. And here are the options. Okay, so first things first, what is the formula for calculating the volume of a cube? Volume of a cube is length times breadth times height. But remember, in a cube, your length is equal to your breadth and is also equal to your height. So you just see V is equal to L raised to the power of 3, because this and this are the same. So we have volume given as 512 is equal to length raised to the power of 3. How do I get my length? It's raised to the power of 3. The only thing that can cancel a power of 3 is a cube root. So I'm going to cube root both sides. Cube root this and cube root this, so that the cube root cancels the cube and I'm left with L. Now, what is the cube root of 512? It's 8, right? So your answer is 8 cm, which is A and is correct. But if you can't remember that the cube root of 512 is 8, you can quickly solve it. How do you do that? Just divide, do your LCM line method, and keep breaking down 512 as all the way down to 1. How do you do that? It's an even number, so you're going to divide by 2. Just keep breaking it down by 2. So if I do that, this will be 2 remainder 1, 5 remainder 1, which is 6. So 512 divided by 2 is 256. Even number again. I go with 2. So let's go. 1, 2 remainder 1, which is 8. Even number again. I go with 2, 6, 4. Another even number, 2, 3, 2. Another even number, 2, 1, 6. I keep going. Now here I have 16. Another even number. 2 can go and it's 8 times. 2 can go and it's 4 times. 2 can go and it's twice. 2 can go again and it is 1. I'm done. Now that I am done, I realize that it's actually 2 all through, but it is cube roots. So I pick them 3, 3, bring out 1. I pick them 3, 3, bring out 1. I pick them 3, 3, bring out 1. So I have 3 2s. So my cube root of 512 is this 2 multiplied by this 2 multiplied by the last 2. 2 times 2 is 4. 4 times 2 is 8. And that's how to get a cube root of a large number you cannot remember. So the volume of 512 has a length of the cube to be 8 cm, and you are done. So if you have enjoyed this video and you have learned something from this video, please don't forget to subscribe. It helps me. Like this video, share with others, turn on notification so you don't miss any math video from me. Thank you for watching.